In today's video, I would like to introduce a very nice problem of Irland Mathematical Olympiad. Here is the following information. We are going to prove this inequality. We have 2 to the 1 over 2 is multiplied by 2 to the 2, all to the 1 over 2 square, and all the way down 2 to the n, and all to the 1 over 2 to the n. The entire thing is strictly inferior than 4. Okay. In fact, it is not too hard inequality, but it needs a small trick in order to get solved. Okay, so go ahead, pause this video if you would like to give it a try to this problem. When you are come back to see the full solution. Okay, let's get into the solution. So I have this following inequality. To write this one on this form: 2 to the 1 over 2 plus 2 to the 2 plus 3 over 2 to the 3, and all the way down to the n over 2 to the n. Okay, this one is the same as the sum of k over 2 to the k, as k goes from 1 to the n. Okay, I'm going to pull out this one and work on this one separately. So I have this sum of k over 2 to the k, as k goes from 1 to the n. As we know, we have 1 is strictly inferior. We have 1 is inferior equal to k, as k inferior equal to n, and n is strictly inferior than infinity. Okay, so always we have this one. This one is always strictly inferior than n. If I'm going to apply the limit here, this one is always strictly inferior than n equal to 1 to infinity to the n over 2 to the n. I'm going to work on this one now. Let's set f of x equal the sum of x to the n, as n goes from 1 to infinity, equals 1 over 1 minus x. This is very known formula as a geometry series, as a convergent series. This one is held when we have x, the absolute value of x strictly inferior than 1. Okay, to have this one as a convergent series, we have to have this condition. Okay, so now, I'm going to calculate this term. So I'm going to calculate the derivative function of this one. We have f prime of x. I'm going to calculate the derivative function of this one in two different ways. Okay, first I'm going to derivate this one. Is giving me the sum of n is multiplied by x to the n minus 1, as n goes from 1 to infinity, and I'm going to multiply by x on both sides. Is giving me the sum by taking the x inside of this sum, is giving me n to the x to the n, as n goes from 1 to infinity. Okay, then I'm going to calculate the derivative function of this one for this term. So again, I have f prime of x. This one is given as 0, is multiplied by this one, minus 1 is multiplied by derivative function of this one, which is number 1 over 1 minus x quantity square. Okay, then I'm going to multiply both sides by x. So this term, we have equality here between this one and this. We have equality. This one is given as this term, n is the sum of n is multiplied by x to the n, as n goes from 1 to infinity. Okay, now let's set x equal half. Okay, I'm going to plug this value of x into both terms. Okay, so we'll get here, this one is given as half over 1 minus 1 over 2 quantity square. So the denominator, it becomes 1 minus 1 over 2, which is 1 over 2. Quantity square is given as 1 over 4. 1 over 2 divided by 1 over 4 is given as 2. Okay, so this value, I'm going to plug also half here, is given as n goes from 1 to infinity of n half to the n. Okay, this one is the same as n over 2 to the n, as n goes from 1 to infinity. This one is taking us to the original one, to this one. Okay, so we found the value of this one equal to, so we found the value of n over 2 to the n, as n goes from 1 to the as n goes from 1 to the infinity equals 2. Okay, so this value equal to here. Since we have this one is this one, so I'm going to take this term to replace it here, okay, which is 2. So we'll have 2 to the 2, which is 4, okay. And then since this one is strictly inferior than this one, so this means this one is strictly inferior than 2 to the 2, which is 4, okay. So I have done this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in the next video. Bye.